Determine whether the function f of x, piecewise function, 2x minus 1 for x less than 1, 2x plus 2 for x greater than or equal to 1 is continuous at x equal to 1. So first thing we want to check is we want to check f of 1. Now with a piecewise function, which one do we plug into in order to evaluate f of 1? Where does the graph exist when x is equal to 1? If I plug in 1, I have to use this second function, because on this second function, it's x is greater than or equal to 1, or equal to 1. So that's why I'm going to plug into this function, not the top one. This is strictly less than 1, not including 1. This is including 1, this one is not. So I'm going to plug it in 2x plus 2, so 2 times 1 plus 2. 2 times 1 is 2, plus 2 is 4. So it exists. Next, we want to check our limits as x approaches 1. So here's the problem, though, with this piecewise function. From the left, we have one function. From the right, we have another function. So we have to check what is happening on both sides of that. So we want to evaluate the limit as x approaches 1 from the left. And we want to evaluate the limit as x approaches 1 from the right. And then we want those two values to equal the same thing. And if they do equal the same thing, then the limit exists, and then we compare it to the function value. So we still have a little bit of a process here. So let's check out limit as x approaches 1 from the left. Which function am I going to use if I want to come in from the left? Which one is from the left? This one is from the left because it's less than. So that means for all the x values less than 1, so that's coming in from the left. So I'm going to use that function to evaluate 1 from the left. So 2 times 1 minus 1. 2 times 1 is 2, minus 1 is 1. And then coming in from the right, I want to use this one. So 2 times 1 plus 2. It's greater than or equal to 1, so that means that's why I'm coming in from the right, so that's why I'm using that one. 2 times 1 is 2, plus 2 is 4. So stop right here. The limits are not equal to one another. So therefore, the limit as x approaches 1 does not exist. So we have some sort of discontinuity here. So let's check out what's happening. Why is there some discontinuity? What does this look like? So just drawing out a rough sketch here. So the first one, 2x minus 1 for all values of x less than 1. So minus 1 is here, up to over 1, and that's not filled in. So I'm going to have an open circle here, and that means my graph is going to look like this. And then the next one, 2x plus 2, x is greater than or equal to 1. So here's 2, and we're picking up at 1. So up 2 over 1, so right here. And that's filled in because it's greater than or equal to, so up 2 over 1. And so here would be my graph. So this is an open circle right here, where this one's a filled in circle because this is greater than or equal to. And so you can see we have a jump. So we have jump discontinuity, because I cannot just go from one graph to the other. I have to pick up my pencil and jump to the other function. So that's jump discontinuity there.